After generating this function, I have to use this x label and y label. You can get this function. Okay, so this is how we can generate an triangular waveform. Okay, similarly here, similar to this all function, you can also generate an exponential function and a square function. Here the direct built-in functions are available. For exponential functions, you are having a function known as exp. Okay, what is the first mathematical expression of exponential function? It is nothing but e power minus at or e power at, whether it is a decaying exponential or increasing exponential. So here you can use the function exp. For amplitude, for a I am using -1, and for t I am using t. So t equal to 0 to 1 to 6. So you will get a decaying exponential like this. Okay. So for this exponential function, similarly we can use a square function to generate a square function. Here the built-in function is available. The built-in function available for generating a square is square of 2 pi ft. Okay, so now we can familiar with how to write how to generate a basic signals, right? So now you try these two things and you generate all the waveforms. Okay, now here we are going to see an important concept known as important concept of subplot. So what you will do, you can, so far what we have seen, we have plotted all the signals in a different window. Now I need to plot all waveform in this format. Okay, so what is the meaning of this? First I need to get an sine waveform like this. Next I need to get a cosine waveform like this. Next I need to have an impulse function. Next I need to have a step. Then I need to have a ramp. Then I need to have a triangular waveform. Then what all the function we have seen? We have seen an exponential. Then we have seen a square function. Okay, you can also generate some other, we can use as sawtooth here, right? Okay, so now I want to generate all the functions in a single window. So when you use plot or stem, what happen is the single signal will be popped up in your window. You will get a window separately like this. Now I want to see all these function in a single window. I am going to use a function known as subplot. Okay, subplot of 3 values you need to give. What is the meaning of this is subplot of which represent first consider this. For example, first I will tell the example. From the example you will understand how to write the index. Here see how many rows and how many columns you are having. You are having 3 rows and 3 columns. So in this plot you have to write 3 rows and 3 columns. The first index is 1. So if I use this subplot before the plot function of a sine waveform, I can get this waveform. Understood? Similarly, if I use subplot of 3, 3, 2 before the plot of cosine waveform, so I will get this function. So this take subplot of 3, 3, 3. So like that 3, 3, 4, 3, 3, 5, 3, 3, 6, next 3, 3, 7 and 3, 3, 8 and 3, 3, 9. Okay, you can also generate all the function in different formats. Here I have used 3 cross 3. Similarly here you can also use any function. So suppose I want to generate all these in 2 rows and 2 columns, right? So how many total functions we have generated? We have generated 9 functions. Okay, if I want to adopt in a single row, how many I need 10. I need 2 rows, right? So this represent first we will represent in different format in rows and column. Okay, so if I am using like this, okay, first here sine, cosine, impulse, then step, then ramp, step, ramp, then triangular, then exponential, here square, here short tooth. Okay, like that also I can generate it. So here I am having only nine signals, so here there is no signal available. Okay, so here you tell how many rows and how many columns are there. Here how many columns? You are having 2 columns. How many rows? 1, 2, 3, 4, 5 rows. So in this case what I have to use is subplot of 5 row. How many rows? 5 rows, 2 column. Then you have to index it. First represent 1, then 5 comma 2 comma 2, like that you need to represent. It is a very simple function, but the one thing you need to keep it in mind is before plot you need to use this subplot. Okay, now we will see these examples how I have written and generated in MATLAB. See, here I have written the programming in an editor window. Before in previous examples I have discussed using this command window, right? Now I have written all these concept in a editor window. See, first I have written for unit impulse, next I have written for unit step. Here this percentage, this percentage, right, this represent the comment line here. Okay, when the MATLAB come to this line, it just skip off this line because it is just a comment line. Okay, for understanding purpose. Then I have generated a sine waveform, then I have generated a cosine waveform, then a ramp waveform, then square waveform, then triangular waveform, then exponential signal. So now here I have used a single function known as subplot to generate all these functions. After that what I have to do is I have to run the program. After pressing this running button, what I will get is I will get an output like this. See, now here I am getting an impulse function, unit step function, discrete unit step function. Here it is a sine function, here it is a cosine, here it is a ramp, square, triangular, exponential. Now see, you can see the functionality of x label. So in this, here like this you will get x label time, y label amplitude, x label time, y label amplitude. So this is what, if you want to name this function, I have forgotten to tell this point, you have to use a function known as title. See here you are having a function known as title, right? So if I want to label each graph, so I can use title, within quotes I can write down the name of the signal. Okay, now you got familiar about this signal. Now why we are generating these basic signals? If I want to test a system, what I need to do, I need to give the known input so that I can analyze the output of the system. So for this purpose I need to generate the inputs. So these are all the inputs we can generate using these MATLAB.